All right, this is the calculator portion of our 2.1 quadratics review. Remember, for every calculator problem, we will round to the nearest thousandth, which is 3 decimal places, except when we're writing the regression equation, we want all the decimals in there. All right, so the following data show fuel efficiency in miles per gallon for all U.S. automobiles in the indicated year. Let t equals 0 represent 1940. So I I'm going to open up Desmos, going to add a table. Remember, they don't want us typing 1940. They want us typing 0 for 1940. That means 1950 would be 10. How many years after 1940 is that? 10. And then 1960 would be 20. It's guessing the pattern here. Yes, this is right. 2000, how many years after 1940? 60, right? So we're going out to 60. Okay, so up here we need to type in these values. So 14.8, 13.9, 13.4, 13.5, 15.9, 20.2, 22. I do a quick check to make sure I don't have typos, which I do not. Then I zoom fit. This definitely looks like sort of a parabola. It's not perfect. I'm going to choose regression. Sorry, I should have, let me read the question over here. Okay, so the first part of the question does say, there we go, use a graphing calculator to find the quadratic regression model. So when you choose regression, remember it will do linear at first. So you need to change this to quadratic. That looks a lot better, right? And so we need to write down this equation here. Do not round the decimals in this equation. When I say round to the nearest thousandth, I mean round your final answers that you calculate to the nearest thousandth. You don't want to round the equation because then your answers will be off. The output is labeled as y. The input was t. So I need to use those two variables when I write this down. So y equals is okay. And then it's going to be all of these decimal places. Instead of x squared, make it t squared. Instead of x times t, and plus 14.81667. So this is the regression model. Use the model to estimate the worst year for average gas mileage for U.S. automobiles. So the worst year would be the lowest point on the parabola because remember the y values are the gas mileage. So in this one, my points are not in the way. I can see what that is. If the points are in the way, we had this in our notes. If you're trying to click on this and you keep getting the data point, remember you can turn them off if you need to. But anyway, this one's fine. So I'm going to click on it to get it to hold there so that I can write this down. All right, so estimate the worst year. So they want me to find the t that goes with that. So this is t equals 16.924 years. This is years since 1940, right? That was 0. Is that right? Yes. So if I had to say what year that was, it's like sometime during, add 16 to this, 1956 is the worst. All right. And that's use the model means don't use the table, use the equation. During which year or years was the average gas mileage 13.7 miles per gallon? So find x when y is 13.7. So we're setting the equation equal to 13.7. There's no need to do any algebra here, any quadratic formula. All you're doing is graphing the horizontal line, y equals 13.7, and you're just looking for intersection points. So they show up as gray. You can click them to get them to stay there while you write down your answer, so you don't have to keep hovering over them. And this is what you round to 3 decimal places. So it doesn't matter what order you give these in. I'm just going to give the lower one first. So 8.948 and 24.900. Again, those are like years since 1940. And you could just give me that. That's fine. If you want to give me the actual years, that would mean like sometime during 1948 and add 24 or 25, I guess, the very end of the 24th year, that'd be 1964. The reason I didn't round up on that, I'm just saying like during these years. All right, so you can just give me the t values. I said x, I should have said t. All right, the next problem says you have 50 yards of fencing to enclose a rectangular region. So give yourself a little rectangle here. The amount of fencing is always the perimeter, because think about fencing. You're not filling a rectangle with fencing, you're putting it around the rectangle. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So we had a couple of these in the textbook work. They're set up the same way. I'm going to say my dimensions are x and y. So for a perimeter, you start here. 2x plus 2y has to equal 50. What is the area of this rectangle? Because that's what we're trying to maximize. The area would be x times y. Well, I want to find the maximum area. I can't do that right now if I have two variables. So you need to solve this perimeter equation for either x or y. It really doesn't matter. I'm going to solve it for y. So I'm going to subtract 2x, divide everything by 2. So 25 minus x. All right. And then what do I want to do with that? I want to sub that in for the y right here. So now the area is x times 25 minus x. If you want to distribute it, you can. We are allowed to use a calculator on this section. So I could either use my vertex formula or I could just graph this and find the vertex. So let me see what happens if I do that. So let's close out of all of our stuff. The only tricky thing about graphing might be like this is zoomed to a weird spot. So you might have to, get yourself back to 0, 0 at least. Let's go ahead and type this in. So that was let's call it a of x equals, split screen here. So there we go. It was 25x minus x squared. Or you could keep it in its factored form. That doesn't matter. All right, what is the maximum area? So the vertex is somewhere up here. Again, you can either kind of drag to find this or, let's see if I can just scroll out. There we go. It's a bit weird scrolling. You also know, like, you could see the zeros. We're at 0 and 5, so the vertex is going to be halfway between those. But click near the top. All right, what is the maximum area? Find the dimensions. So I have two things to do. All right, so the vertex was here, right? The vertex, let's just write that down. The vertex was 12.5, 156.25. Which two dimensions does the vertex represent? The inputs are the x values. What are the outputs? The areas. So what is the maximum area? I've got that answer right now. Max area equals 156.25. And we're talking about, was it feet? No, it was yards. So this would be square yards. What are the dimensions of the triangle? Well, I know x. I know x is 12.5 yards. Remember, we have an equation for x and y. Y is 25 minus x. So 25 minus 12.5 means y is also 12.5. Fun fact, if you have a rectangle, the largest area will always be a square. So as long as you're not putting a third line of fencing down the middle, you can know that this answer would have to be a perfect square to get the largest area. Speaking of fencing down the middle, let's take a look at the next problem. You have 600 feet of fencing to go around the perimeter of this rectangular region. Fencing will also split the rectangular area in half. So not only do we have fencing here, but we have it here and here. And I'm going to make x like this little half dimension here. Oh, why did I do that? Let x be the vertical. Okay, fine. So let x be the vertical side length. That goes against everything I want to happen, but whatever. X is the vertical and Y is the horizontal. Okay. It really does not matter, but I'll follow the directions. Write an equation for the amount of fencing that will be used. All right. So fencing again is perimeter. So this is not just 2x plus 2y. We have 4y plus 3x is equal to 600 feet of fencing. Write a function a in terms of x for area. What is the domain of the area function? So in order to do this, it would start out like this. What's the area of the entire thing, these two squares here? So it's, or not squares, these two rectangles. So the area would be length times width. So it would be 2y, excuse me, times x. We're supposed to write a function in terms of x. That means that we need to get rid of this y right here. So we need to solve our perimeter equation for y. So subtract 3x, divide by 4. And that's going into the area equation. So area is now equal to 2 times 600 minus 3x over 4 times x. I don't like having this all separate like that. I would like to reduce it a little bit. This is not required, but 2 over 4 reduces. So I can say area is, let's just put this x out here, x times 600 minus 3x over 2. So here's my area function. I'm going to leave it like that. All right. And then what about the domain? So think about this now. For the domain, I need areas to be positive and not 0. So x has to be greater than 0 because of this. And 600 minus 3x also has to stay greater than 0. I don't want it to equal 0 because then I don't have any area. I don't want it to be negative. So negative 3x is greater than negative 600. Divide by negative 3, so flip this symbol around. X is less than 200. So the domain is anything between 0 and 200, but not including those two dimensions. That's your domain. Anything else will give you a negative area or 0 area. Use the area function to determine the dimensions that will produce a maximum area. Also, find the maximum area, include labels. So this is what we did before. Remember, I'm going to write my area equation so it's a bit nicer looking. And I have this domain that's like 0 is less than x, which is less than 200. So let's just go ahead and graph this and find the maximum. I don't want to use vertex formula if I have a calculator. I would rather just use the calculator. If for some reason you can't get the graph to show, that's a different story, but type it in as a of x. I'm hitting divided to make a fraction. X times 600 minus 3x over 2. And remember, when we're given a domain like this, you can zoom fit, because look how weird my graph is right now. You can zoom fit if you add a table. We've done this before. Make it go from 0 to 200 and make this a of 0 and a of 200. So I want to make sure I can see those 2 points. Now, sometimes with a parabola, that just gives me the zeros. I would like to see the vertex too. What's halfway in between those? How about we throw in a of 100 as well? I want to find the vertex, so I would like to see it without having to scroll to a weird thing. There's the vertex right there. So let's write this down. So on this one, the vertex from my graph was something. It was 115,000. Remember, this is a of x, so the 100 is an x, the 15,000 is an a. So what is the max area? The max area is 15,000 square feet. What are the dimensions? X is 100 feet. What would y have to be? So remember, you have an equation for y right there. Y would have to be 600 minus 3 times 100 divided by 4. 600 minus 300 divided by 4 You can do that in Desmos too if you want. That's just 300 divided by 4. 75. Okay, so, oops. So y is 100 feet, or sorry, x is 100 feet, y is 75 feet. The max area is 15,000. These are not perfect square corrals because we have fencing down the middle, so it's not possible to make it a nice square, but it's as close to a square as you can get with that dimension of fencing. What x values of the rectangular region will give an area of 5,000 square feet? So now we are setting our area equation equal to 5,000, and this is when x is about equal to. Remember, do not solve this algebraically. It's so much faster to solve by graphing, and it's a good skill to have. It means you understand how all these things connect. So I don't know if I can write a equals, let's see, equals 5,000. No, I don't think so. I would just do y. Anytime I'm solving, I do y equals. And I have the two answers right there on my graph. So this is one dimension is when x is, split screen here, 18.350 feet. And another time is when x is 181.649, would round up, 650. Remember, you have to round to 3 places and you have to round correctly. So just be careful with it. All right, and that was the last question with this area. We had a problem or two like this in our textbook homework on Thursday. So among all pairs of numbers whose difference is 16, find a pair whose product is as small as possible. What is the minimum product? This is just like fencing and area. I'm just not talking about fencing and area. I'm talking about all pairs of numbers whose difference is 16. So x minus y. When I subtract them, I get 16. You could do y minus x. It doesn't matter. I want the product of the two numbers, which would be x times y, to be as small as possible. So this means that I'm still finding a vertex, but the parabola I get should be something that a parabola that opens up. All right, so solve this equation for x or y. I'm going to get x by itself because then I can just add y over and I won't have subtraction. Now sub that in for x. So now p is equal to, instead of x, it's 16 plus y times y. This makes p a quadratic. You don't have to distribute, but you can. And I just need to find the vertex. All right, so we could use vertex formula on that. It might be just as fast as using Desmos, especially with things being zoomed, but I just want to show you just in case. All right, so p of x, remember you need to use function notation in Desmos. I don't want to do the y thing, so I'm going to type it in as 16x plus x squared. If you use the y's, it can graph a sideways parabola, but it just gets a little confusing to find the right number. So I'm going to go off of this. I can see the vertex right here. There it is, -8, -64. And it's important to know what two variables the vertex represents. So let me write it down first. In this equation, the vertex is y, because that's the input, and the output here is p. So I know that y is -8. What would x be? X would be 16 plus y, which is 8. And the minimum product is -64. So the minimum product is -64. The pair of numbers is 8 and -8. It doesn't matter which one's x, which one is y. Two positive whole numbers have the following sum. The sum of the first and twice the second is 32. So the first number I'm calling x plus twice the second number is 32. Find the two numbers that have the largest product. Again, I'll use p equals x times y. I like to just solve for the one that doesn't involve fractions, so I'm just going to subtract 2y over here. If I were to solve for y, I would have 16 minus 1/2 x, so that's just a little more annoying to work with. Plug this in for x, so 32 minus 2y times y. If you want to distribute that, that's 32y minus 2y squared. So let's type this into Desmos. So p of x this time is 32. Again, ignore the fact that it says y, just do x minus 2x squared. And I want the vertex of that right there, 8, 128. So vertex equals 8, 128. 8 is the y coordinate, 128 is the max product. So find the two numbers that have the largest product. So y equals 8, x would equal 32 minus 2 times 8, which is 16. So the two numbers are 16 and 8. The max product, I know it didn't ask me, but why not? The max product is 128. You could also, you had y equals 8. Remember, 128 is just what you get when you multiply x and y. So 128 divided by 8 is another way to get the 16. Now this is on the calculator part, but it would be non-calc. So I will go through these just in case I didn't in my other video. Solve each quadratic equation using the most efficient method. So remember, quadratic formula works for everything, except sometimes it takes longer to do it. So I always try factoring first. If something doesn't factor, I use quadratic formula. If something can be solved with square root method, then I do that. So for example, first off, this needs to be equal to 0. So I need to add 3. And I'm thinking, hey, 4 and 3 are 12. That's pretty close to 13. This probably factors 4x and x. I'm going to give it a try before I go into quadratic formula. If I make it 4x and x, and I make this 3 and 1 in that order, I get 12x and 1x. And those can be negative 13x if they're both negative. That works because negative 1 times negative 3 multiplies to positive 3. So I did not need quadratic formula. If 4x minus 1 equals 0, 4x equals 1, x equals 1/4. X minus 3 equals 0, x equals 3. So those are the two solutions. Part B is already equal to 0. This one does not factor because there are no numbers that multiply to 17 that add or subtract to negative 2. So I have to use quadratic formula for this one. So it's opposite of b plus or minus square root of b squared minus 4 times a, which is 1, times c, which is negative 17, all over 2 times a, 2 times 1. All right, I need to do 4 times 17, so do that off to the side here, 28. I'm getting 68 for that. Okay, so it's positive 68. So this is the square root of 4 plus 68. So now I'm at 2 plus or minus the square root of 72. I don't know why I made that so large. The square root of 72, when I add that together, over 2. This square root can be simplified. 72 has perfect square 36 as one of its factors. So this becomes 2 plus or minus 6, radical 2. And because I can divide 2, 2, and 6, all three of those have to be divisible by something, I can reduce this. So divide everything by 2, you get 1 plus or minus 3 radical 2 divided by 1, so I'm not going to write that. Now on this last one, if I wanted to factor or use quadratic formula, I would have to square out this binomial and get it equal to 0. But remember, if you can get rid of the squared because you can isolate it by using the square root method, then this is probably going to be faster. This leaves me with 8x minus 3 equals plus or minus radical 5. I'm not putting an absolute value around this because the plus or minus takes care of that. I just need to solve this, so add 3 Now you can't actually combine terms, so I'm just going to put a positive 3 out in front here, and then divide the whole thing by 8. This looks like a solution to a quadratic formula. So if you would have squared this out and subtracted 5, this is what you would get if you correctly did quadratic formula. But this was a lot faster. All right, that finishes our calculator section. These are the only types of applications I'm going to give you. So know how to do a fencing problem and know how to find a max or min product given two numbers. And the only other thing we had was quadratic regression.